Bismillahirrahmanirrahim. Guys, we are here on to this. This is the, let me see which year is this. This is June 2020 and variant 4.1. And it's basically a mechanics paper. Okay, let's start solving this paper. The very first question is about resolving the forces. So if you, it says three coplanar forces of magnitudes 100, 50, and 50 act on a point A. As shown in the diagram, the value of cos alpha is 4 by 5. Now you don't be deceived by this value of cos alpha, and don't start finding the value of alpha over here. Okay, simply draw a triangle. Okay, and this should be a right angle triangle. Here it is your alpha, this is 4, this is 5, so this is going to be 3 over here. Okay, so now if cos alpha is 4 over 5, it means your sine alpha will be 3 over 5. Okay, so it says find the magnitude of the resultant of three forces and state its direction. This time we're not given that all these three forces they are in equilibrium. Instead, we have to find the resultant magnitude and its direction. So this 100 Newton force is already a horizontal force. We love this force because this we don't have to resolve it, but we'll have to resolve this force of 50 Newton here. Thank you. Okay, so this will be 50 sine alpha. This is going to be 50 cos alpha. Okay, now to avoid any overlapping here, I'll be resolving this force like this. Okay, if this is alpha here, this is alpha, so this one is going to be 50 sine alpha, and this one is going to be 50 cos alpha. Now, one thing is getting clear from by looking at the diagram here, that the Ry is going to be 0 because there is upward 50 sine alpha and there is downward 50 sine alpha. So this is 50 sine alpha minus 50 sine alpha. So this is going to be 0 here. Okay, so this is going to be an easier question for us now because one of the component has become 0. Now your r-axis, there are two rightward horizontal forces. They are both like 50 cos alpha, and then there is plus 50 cos alpha, and then there's minus 100. By the way, I'm moving out of the page while you people are attempting your exam. Stay within these margins here. Try to write everything on these lines here. Okay, so this is going to be 100 cos alpha. Cos alpha, we know that is 4 over 5, and then there is minus 100. So this is minus 20 newtons. Okay, so that means this is this resultant over here. I don't need to apply that formula that this is going to be rx square plus ry square, because one of the components is already 0. It's this r right now is just like a vector minus 20 0. So you see that its direction is quite clear. This is moving like leftwards. You can say that this R is 20 newtons in the direction of the force with the magnitude 100. You have to write all of that. R is 20 newtons. The resultant is 20 newtons in the direction of the force with the magnitude 100 Newton. Okay, we didn't have to use this formula. We didn't have to use the formula for the direction, that is tan inverse of ry over rx. Okay, bachcho? Okay, question number 2 is clearly about the connected particles. It says a car of mass this is towing a trailer of this mass along a straight horizontal road. So we have a straight horizontal road, okay, like this. So here is the car, okay, and here is the trailer. So this is my car and this is my trailer here, okay. We give the masses. The car and trailer are connected by a light rigid tow bar. So I have told you guys that whenever the particles are connected, you have to have the same tension. If it's the same string, same thread, same rod, whatever it is, okay. So So this is the tow bar. Tension in the tow bar has been shown here, okay? And next, it says the car is accelerating at 1.5 meter per second square. So if the acceleration of the car is 1.5 meter per second square, and this tow bar is taut, okay? It is not slack. So it means the acceleration of this trailer will also be 1.5 meter per second square, okay? Next, it says there are constant resistance force of 250 newtons and 100 newton. Like car pay, there is 250 newtons that is backward, 250 newtons, and this is backward 100 newton force on the trailer. Okay, so it says find the tension in the tow bar. So you can use this car motion, you can use consider the trailer's motion, you can consider this as a whole, as a system. But if you just consider the trailer, because since you have to find the tension, so you see that clearly there is a tension in the tow bar that is moving the trailer forward, okay? And then there is this 100 newton force, that is the resisting force, and that is equal to ma. The mass of the trailer is 400 times this 1.5. So this gives you 700 newtons, the tension in this tow bar. Okay? So we have used here F equal to ma, by the way. Okay, we love this formula. The next it says find this power of the engine of the car, okay, of the car at the instant when the speed is 20 meter per second. Now, obviously, there has to be a driving force that is pushing this car forward here. So this is the driving force here. And remember, the powers formula, it has the driving force in it. Okay, that is F into V. So we have to determine the power. Now, before we do that, we need to determine that what is the forward force here. So this forward force, that is, we are considering the car right now, minus, so there's a forward force provided by the engine, obviously, and then there are two forces which are like, resisting this motion here. One is the tension in this tow bar, this one, okay? Oh, uh, okay, so this one here, okay, and second there is the resisting force. So this is going to be fd minus this t. We have already calculated that t, which is 700, plus there is this 250, and that is equal to ma. The mass is 1800 times 1.5. Okay, so this is going to be 2700 minus 950 है ना? So that is 1650. Yes.
So it will be plus 950.
Oh yes, plus 950, because this is minus here. Okay. So this is 3650, Hannah. This is 3650 times the speed that is given to us, that is 20 here. So I think that is 7300. Hmm?
73,000.
Okay, 73,000 watts. I should always keep calculator. I really make silly mistakes while calculating this. Okay, this is 73,000 watts. That is the power the engine is providing to the car. Okay. The third question is from about the vertical motion here. It says a particle piece projected vertically upwards with speed 5 from a point A, which is 2.8 meter above horizontal ground. Okay. So let's say this is your horizontal level, and here is a point A, which is uh, 2.8 meter above the ground level. Okay. And we are projecting this up with the speed of 5 meter per second. So it says find the greatest height above the ground reached by P. So people, you know that when it reaches the highest level here, okay, so what will happen? Suppose it reaches here. So when it reaches the highest point, so that means here the speed should be zero. The final speed should be zero. When the speed is zero, that means it has attained the highest level above the ground. ठीक है ना? So Now we have v0, we have this u equal to 5, and we have one more thing here, that is your acceleration. That is going to be minus g. And remember, g has to be 10 here in your mechanics. Okay. So we have to find that greatest height. So let's find that s. So the equation that you will be using, that is 2as, that is v square minus u square, 2 into minus 10 into s, that is going to be 0 minus 5 square. You simplify this, you get 25 over 20, that is 1.25. I remember all this because we did this question yesterday as well. So this is your distance above the point A, and this was already 2.8 meters above the ground. So the total height, the greatest height above the ground, remember this, okay? So that is going to be 2.8 plus 1.25. So that is 4.05 meters. Next, it says find the length of the time for which P is at a height of more than 3.6 meter above the ground. Okay, 3.6 meters above the ground. Okay, so when it is above this the ground here, so you guys see here that if for example this is your ground level over here, okay, and it has to be 3.6 meters above the ground. Okay, so you were already 2.8 meters above the ground here, Hannah. So that means you have to go zero point 0.8 meters further up here, Hannah. This is your zero point 0.8 meters. So this is going to go up and then going to come back. So we have to find out these two times basically when it is above 3.6 meters above the ground. Okay? So you already have the initial speed here, that is going to be 5 meter per second. You know that your acceleration is minus 10 meter per second squared. And now you know that the distance is also that is going to be more than zero point 0.8 meters here. Okay? So this is more than zero point 0.8 meters. So which equation I should be using here, guys? Hmm? Yes.
ut plus half at square.
Yeah, very good. That is going to be s equal to so I would say that this ut plus half at square is now more than s. Okay, so this is your 5t minus 5t square is greater than zero point 0.8. Okay, so you please solve this inequality. This would become minus 5t square plus 5t, and minus zero point 0.8 is more than 0. You multiply both the sides with minus here. This is 5t square minus 5t plus zero point 0.8, and that is less than 0. You solve this through the quadratic formula. I remember since we did this already. So one of the time is zero point 0.2, the other time is going to be zero point 0.8. So this inequality solution becomes between zero point 0.2 and zero point 0.8. So we have to give the length of the time. Okay. So that is going to be the length of the time is obviously zero point 0.8 minus zero point 0.2. So that is going to be zero point 0.6 seconds. That is the time when this particle was above 3.6 meters from the ground level. Okay. We are on to the fourth question. This is a question on the rings. Okay, some people really don't like such questions. Okay, but you see, it's the diagram shows a ring of mass 0.1 kg threaded on a fixed horizontal rod. Okay, now this is the mass is 0.1 kg. Just remember that. Okay, and the rod is rough, and the coefficient of friction between the ring and the rod is pointed. Now, when you have this roughness here, so you must have that R with you. Okay, since when you have to determine that frictional force, so that is equal to mu r. Okay, so we are given the mu here, and let's see what is that r going to be. So guys, I'll be showing the weight down here. That is going to be 1 Newton. Okay, and then there would be r right opposite to it. Okay, this is your r over here, and then I'll be resolving this tension here as well. Okay, this is going to be t cos 30. This one is going to be t sine 30. Okay, it says a force of magnitude t Newton acts on the ring in the direction this. downwards in the vertical plane containing the rod. Initially, the ring is at rest. Okay, so this means it is going to accelerate. So the initial speed is going to be 0 meter per second. Find the greatest value of t for which the ring remains at rest. Okay, the greatest value of t. So we are going to consider that. Um, I mean, the limiting equilibrium over here, okay? So we're going to assume that this does not move, but it is about to move maybe, okay? So that means this is your forward force here, that is T cos 30, and you will have the frictional force in this direction over here, okay? That is your X. Let me call that X. So we have to keep that. Um, this is the greatest value of t for which the ring remains at rest. So that means this x has to be more than t in a way. I mean, this t cos 30. So let's determine this r now, first of all. So, guys, what is your r right now? Hmm? Yes? What is r?
It's 1 plus
1.
0.5t.
Yeah. So, like normally people think that this R is just opposite and equal to the this weight over here. But remember, at this point, you have two vertical forces acting downwards. Okay. So therefore, this R right now is going to be 1 plus T sine 30. And let me write it as T sine 30. And we know that sine 30 is half. So this R is going to be 1 plus half T. Okay. Or T over 2, or maybe 0.5 T. And now we can determine that frictional force that is going to be mu r. Mu is zero point 0.8. Okay, so zero point 0.8 into 1 plus t over 2. So if this has to be at rest, that means x has to be greater than or equal to this t cos 30. Okay, so x is 0.8 plus 0.4t, because if you simplify this, this is zero point 0.8 plus 0.4t, and that is greater than or equal to, this is under root 3 over 2t. Okay, so let's write it this way. Zero point 0.8 is going to be greater than or equal to, this is under root 3 over 2 minus, I'm taking this t as common here. Now please people tell me, what is this? T is going to be less than or equal to, can you simplify this? Zero point 0.8 over under root 3 over 2 and then minus zero point 0.4 here. Yes. What is this t, guys? Hmm. Okay, this is less than or equal to 1.72. So the maximum tension that we can have, that is going to be T is equal to 1.72. But I'm using this less than or equal to sign here because it says the greatest value of T for which the ring remains at rest. So that means, because this is up to you how much tension you apply here. So you have to keep it in such a way that this does not exceed this frictional force over here. So I'm keeping this frictional force more than this T cos 30, this component of this T that is parallel and opposite to this frictional force here. Okay, so that is the reason for using this inequality over here. Okay, and for example, if it had to be, for example, if the question was that what is the minimum force required so that this starts moving, then you could have reversed this sign here, because now you would wanted this component to be more than, it should overtake this resisting force so that this should start moving, and that would also be the same 1.72. Okay, uh, in fact, you will be keeping the just the equal mark over here because you want this to move, because if you just kept that equal to as well, so that would be the point of the limiting friction actually. So if you want to know the minimum force required so that this starts accelerating, so this has to be just above 1.72. I hope you got it. Yes. Hmm. Then it says find
Sir, I
the,
have a question.
yes beta, yes, yes.
Sir, like if we were considering it to be a minimum force, what would be the force acting in the left side direction then? Like what would you equate it to?
Left side, where the left side? Here, beta. Where
Yes,
are
sir.
yeah, left side. This X. Hmm?
Yes, sir. In the case if we were taking the friction to be in the side of t cos 30.
This can never be possible. This will always be opposite. There are just two horizontal forces. One is the T cos 30, other is this resisting force. And this X is only here because this rod is rough. Otherwise, if this was a smooth rod, then there could be only one force parallel to, and then this could easily move whatever the tension you apply here because there would be no resisting force. Okay?
So then how would we find the minimum value of t in this case?
Minimum value that is just above, like that can be anything, yaar, because there is no resisting force. Dekho, the minimum force depends on the amount of this frictional force. The bigger is this frictional force, the more would be that minimum force required here, है ना? Or that would depend on the roughness, on the, there are many factors on the mass of this ring, because the heavier is the ring, the more would be R, okay, and greater would be the frictional force. So there are many factors. Okay? And if it's
Okay,
just a
sir.
smooth rod and smooth ring, then this can easily be moved with any little amount of the force. Okay? As next it says in the second part, he's saying that what is the acceleration when your t is 3? Let us read that question again, because we just missed that while discussing this. It says find the acceleration of the ring when t is 3. I'm going to go back. I don't want to erase all this working and all this diagram here. Okay, so it says find the acceleration of the ring when your t is 3. Now, can I use the same resisting force here? Hmm?
No, sir, we are going to have to substitute TS3 this time.
Yeah, exactly. So we can use all these expressions actually, Hannah. So let me clear this area and we can determine x now, okay? And we can determine t cos 30 as well, okay? So for the second part, bacho, uh, now this is going to be F equal to ma. Our darling formula is going to be used here. So the forward force would be T cos 30. That is 3 cos 30. And the backward force now would be, that is zero point 0.8 plus zero point 0.4 times 3. Okay. This is zero point 0.8 plus zero point 0.4 times 3, and that is equal to ma. Mass is zero point 0.1, and guys, if you simplify all of this, you can get the acceleration. And please someone tell me what is the acceleration after solving all this equation. Put all of
5
this
point.
in your
5.98.
calculator and divide it by zero point 0.1. Yes, beta, what is the answer?
5.98.
Okay, 5.98 meter per second square. Do not ignore the units, okay? So that is your part B's answer. Okay? Now we have 5 minutes left for this session. Let's see if we can try the fifth question. Okay, I think we should do that in the next segment, okay?